So, for the first type of work application, work required to stretch a spring. So, if an ideal spring is stretched, so for example, this one, this spring is expanded using this force F. So, kining spring na ni siya ginatawag nga K or yahang di ato na lang yan na lang nato. So, na siya K. For example, K sub 1 kay isa raman ni siya ka spring element. So, kini si K ginatawag ni siya og stiffness coefficient. Okay? So, based ani kang K, nara na, kini si K, constant na ni siya, so, dimensionless. Then, si spring, mao ni siya, ang yang, for example, kini yung displacement ni spring, since imo man ni siyang applyan ani nga force, meaning na expansion na may tabo. So, may tabo ani, may mo ni ana, no? Kung na-expand na siya, meaning, gikan na to yung initial state, mo niyang first na, no, na kay, for example, na kay x sub 1, na nasa dayon kay x sub 2 then he. Then, this one, kini mo, ninimuhang delta x. Okay? So, kung nag-stretch ka og spring, kung nag-compress pod ka, so, ang force going dadhi, so, kung compression, padulong dire, no, na ipit ang imuhang spring. So, by Hooke's law states that the force F is equal to Kx, or your stiffness coefficient times your distance, your x. So, for our example number 1, a spring has natural length of 1 meter. A force of 25 Newton stretches the spring by 1/4 of a meter. Determine how much work is done by stretching the spring. For letter A, 2 meters beyond its natural length, and B, from a length of 1.5 to 2.5 meters. So first, we are going to determine the spring constant K, okay? Because the force 25 newtons, when x is 0.25 meter, we can use, or 1/4 of a meter, we can use Hooke's law to determine K. So F is equal to Kx. So, given force is equal to 25 newtons, x of, since ang nadinino, a force of 25 newtons stretches the spring by 1/4 of a meter. So, naatay, murag, ginatawag na to nga initial nga, setting. So, pag na daw kay 25 newton nga force, nag-stretch daw siya og 1/4 of a meter. So, makakuha din tag K, or spring constant. One-fourth of a meter is equal to 0.25 meters. So, K is equal to 25 Newton divided by 0.25 meter. which is equal to 100 Newton meter. Sorry ha kung nakaingon ko kaganina nga dimension la si K. Ang yang dimension by the way is Newton meter. Okay? So now we have kung f is a function na of x or kung ato nang gamiton tong work nga nga formula, so f of x kung function naman si f ni x is equal to 100x using Hooke's law. Okay? Kung atong gamito na ni si Hooke's law. Hence, to find the work done aning kining A nga setting and kining 2 meters beyond its natural length ato siyang i-solve using the equation for A. So, work is equal to, balikan na to ang general formula no, work is equal to f of x dx when x is equal to A and x is equal to B, or simply f of x dx from A to B. So, given ang given 2 meters beyond its natural length. So, from 0 or from the natural length to 2. Mao na ang ang limit. So, f of x is 100x. So, integral of 100x dx from 0 to 2. So, now we can find the work required to stretch the spring 2 meters beyond its natural length. So, by integrating this, we have from 0 to 2. Okay? So, we have 50x squared from 0 to 2, which is equal to 50 times 2 squared minus 50 times 0 squared. Then we have 200 Newton meter or 200 joule. So now, let us proceed with the next na gipangayo or required. From a length of 1.5 meter to 2.5. So, medyo tricky ni siya nga pangutana. Okay? So, from the length of 1.5 meter, wala siya nag-ingon nga from its natural length. Okay? So, by the way, gihatag pod sa tuwa ang natural length of 1 meter. Okay, so unsa may importance ana nganong kinahanglan man nato na siya i-mind. So wait lang atong So ang natural length meaning ana wala pay nahitabo sa iya ha. Like for example, ang imuhang spring nga kini siya mao na bali ang imuhang kini siya nga distance x is your, for example lang ha, x is your natural length. Bali sa pag-fabricate sa iya ha, pag-manufacture sa iya ha, maugyod ni ang iyang designed na length. Wala pa'y compression or expansion nga nahitabo. So, ang gihatag sa tua dinhi is from a length of 1.5 meter to 2.5 meter. Meaning, dili ta mo limit og 1.5 to 2.5 diretso sa ato ang integration na sa atong integrand. Okay? So, ang iyang manggiingon diri is, dili pareha aning A nga 2 meters beyond its natural length. Okay? So, nilapas siya sa atuang natural length. Dinhi, from a length of 1.5 to 2.5 meters. So, given the natural length of 1, so, for example, no, gikan lang siya dinhi, mao man ni 1 meter man ni siya. So, gikan daw dara, niisbog lang daw to, sorry. Gikan dara, niisbog ra ni siya og 1.5 meter or 1.5 to 2.5 daw. So, 2.5 meter. So, therefore, ang ato ang limit is gikan ra ani kini siya which is 0.5 ra. Okay? 0.5 meter lang. 0.5 meter to 2.5 minus 1 is 1.5. Okay? So, gikan na niyang gihatag nga length, atong subtract ang iyahang natural length nga 1 meter. So, we have 0.5 to 1.5. Maura na ang nakatricky ani nga problem. So, same ra gyapon sa atong gibuhat ka ganina. Work is equal to integral of f of x nato is 100x dx from 0.5 to 1.5. Okay? So, we have 100 over 2x squared from 0.5 to 1.5. Which is equal to 50 times 1.5 squared minus 50 times 0.5 squared, which is equal to 100 Newton meter or 100 joules. So that is our final answer.